Hello everyone. In our previous video, we introduced the 555 timer and discussed its internal structure. In this video, we are going to talk about the operation of the timer. Now let's look at the typical 555 timer circuit working in a stable mode, which means it produces only the continuous square wave. So in the circuit, we have two resistors here, RA and RB, and one capacitor, C. So I think it's very clear to understand here that the capacitor is charging through RA and RB from a VCC, assuming it has a 6 volt. And also it's discharging through RB and the discharge transistor here, T1. So the threshold and the trigger inputs are short circuited and connected to the capacitor, and also the discharge pin is connecting the point between RA and RB to the discharge transistor. So here we visualize the capacitor voltage VC with a plot assuming the 6 volt power supply. We displayed three critical voltage levels here: 0 volt, 2 volt, 4 volt, which is 1/3 of the VCC, and this one is 2/3 of the VCC. To illustrate how the output depends on the VC, the capacitor voltage, we also include another plot here showing the output, which switching between high and the low. Now let's break the timing operation into steps. Actually, we have 3 steps here. So they are the steps of charging or discharging of the capacitor. So it has an initial phase, a charging and discharging phase. So in the initial phase, the capacitor is initially discharged and it has a 0 volt. So which means that the trigger and the threshold also has a 0 volt input. So this gives an initial values of 1 for the set and 0 for the reset. So the output of the flip-flop goes to high. Since we have a 0 at Q prime, which turns the transistor off. All right, so when the charging phase started, the capacitor starts charging from the power supply through RA and RB. When the capacitor voltage reaches 1/3 of the VCC or supply voltage, which is 2 volt, then the capacitor, the comparator 2, triggers and goes to 0. The reset is still 0. Since 0 and 0 from the truth table, and there's no change from the output, so it's not gonna do anything yet to the flip-flop outputs. And the capacitor is still charging when it comes to the level of 2/3 of the VCC or the supply voltage, which is 4 volt. Then the comparator 1 is going to be triggered. Then it will set to 1. The comparator 2 is still 0. Then this time the flip-flop is in the reset position. Then it resets the output. Output goes to 0, but Q prime goes to 1, and this triggers the discharge transistor. So this starts to help to capacitor discharge through RB and using the transistor here. When the capacitor voltage reaches 1/3 of the VCC, then the comparator 1 also triggers, turns to 1, and since it's the set position, then the output goes to 1 and the Q prime goes to 0, which offs the transistor, then cutting this path to stop capacitor discharging. and it starts the charging again. So this then the capacitor charges to 2/3 of the power supply again. Then the comparator to triggers and it goes to 0, but this time the comparator 1 goes to 1. Then this time it resets the output, then output goes to 0, and then Q prime goes to 1, and the transistor starts as transistor is goes the transistors is also is on. Now it allows to the capacitor discharge again. So this cycle repeats itself. Then the result is in a square wave output with the timing defined by RA, RB, and the C. All right, that's it. Thank you so much for watching. See you in the next video.